All right, Ivy, I wanted to make a quick video talking about a few things. The first thing is estimating numbers. We're going to talk about compatible numbers as a way to multiply mentally, but also we can estimate by rounding both factors to the nearest one, or rounding a factor up and rounding a factor down. So there's different ways that we can estimate by rounding. The second thing we're going to talk about is reviewing where to put the decimal point. We can first talk about it in terms of multiplication, where it goes, and then also after we add and subtract decimals, where do we put the decimal point? And the last thing I'm going to do is review some of the difficult word problems we saw on the practice test. So the first thing I want to go over is estimating, using estimation to find a product. So if we look at this first problem, 79 times 0.29, right? When we think about estimating, we want to look at our choices A, B, C, or D and find numbers that are close to the numbers that we are starting with, right? So if we look at 79, okay, how would we want to round that? Well, we can round it up to 80, right? 79 is really close to 80. And so if we look at our other choices, there are two choices, B and C, that have 80, okay? And that's very close to 79. A is 100, that's way too high. D is 90, again, that's a little too high. So when we think about estimating, we want to think about or our best estimate, a value that is close to the number so that we get an as accurate of an answer as possible. So now we can look at 0.29, okay? So 0.29, if we round that up, that's really close to 0.3, okay? So again, thinking about when we round, what numbers are close to the values we're given. So we can see here, B is going to be our answer, 80 times 0.3, okay? C, 0.2 is rounding down, and 0.29 is closer to 0.3 than it is 0.2, okay? Let's look at the second problem here, estimate the product of 204 and 0.46. So when we were doing this together, we wanted to think about compatible numbers, right? So when we look at 204, what number are we comfortable using that it's close to? And I remember you saying, well, 204 is very close to 200, right? And 0.46, we can round up to 0.5, okay? And in here, we just have 200 times 0.5, or 200 times 1/2, which we know is 100 in our head, okay? And so in this case, the method we used was compatible numbers, which allows for easy mental math, okay? So again, maybe you can try this bottom one right here. So maybe pause and try. So we're looking at 26.4 times 2.7, okay? So I want you to try to use compatible numbers to multiply this. So a number that we're really comfortable using that's close to 26.4 is actually 25, right? That's a number that we're very comfortable using. And 2.7 is very close to 3, okay? So now what we're doing is 25 times 3, right? And we will get 75, right? Because we know a quarter is 25, 3/4 are 75 cents. That's the whole point, is getting values we're very used to using so that we can do the math quicker, okay? So now let's talk about the idea of overestimating and underestimating. So when we were going through problems, it brought up something like Mario is buying 4 pounds of oranges. Estimate how much he spends, and an orange is $1.69 per pound, right? And if we want to estimate this, we can pick a value that is easier to use. So 1.69, if we rounded up to the nearest dollar, right, would be $2. So, and we wanted to figure out how much would it cost for 4 pounds. Well, we just multiply by 4 and we get 8, right? So now we have to think about, is this an overestimate of the actual cost or an underestimate? And we need to think about, well, what did we do to our value? $1.69. Did we round up? Do we round up? Or did we round down, right? Well, in this case, we went from $1.69 to $2, right? So we went up in value, so we rounded up. And when we round up, we're going to get an overestimate. Okay. So now let's look at this other one. Nico is buying 6 pounds of tangerines. Estimate how much he spends. And again, a tangerine in this case is $1.19 per pound, okay? So again, let's round $1.19 to the nearest dollar. And in order to do that, we're gonna round down, right? Because $1.19, we're gonna round down to a single dollar, because that's what it's closest to. And now we're going to multiply by 6, because it's 6 pounds he's buying, and we get $6, okay? So, did he overestimate or did he underestimate? Well, first we have to decide, did we round up or did we round down? Well, we went from $1.19 to $1, so that's less. $1 is less than $1.19, so we rounded down. And because we rounded down, in this case, we're going to underestimate the actual cost, okay? I hope that makes sense. When you round up, you overestimate, and when you round down, you underestimate. Okay, now let's move on to where are we going to put the decimal point. So let's look at multiplication. When we were doing examples with exponents, I noticed that what you like to do is convert the exponent or multiply out the exponent. So you would say, oh, 10 to the 3. You would ask me, is that equal 1,000? And I would say yes. And then you would do 0.85 times 1,000. And you would write it out in standard form. So you would do something like 1,000 times 0.85, and it kind of got messy because you would start doing 5 times 0 is 0, 5 times 0 is 0. You would add all these zeros, right? And I think what I said for you to do instead is, if you want to do it this way, right, put 0.85 on top, put 1,000 on the bottom, and kind of let these zeros dangle off, right? So we can kind of let those zeros dangle off and we'll add them back in. And now all we're doing is multiplying this 1. So we do 1 times 5 is 5. 1 times 8 is 8, right? 1 times 0 is 0, so we can kind of ignore that. And then we bring down these zeros, okay? So right now we have 8, 5, and 3 zeros. And so then we ask ourselves, well, how many decimal points, or where do we put the decimal point, right? And what we do is we look at our factors, the numbers that we're multiplying, and we count how many there are. So right now we have an 8 and a 5, and then you would write 2 right here. So we say, okay, that means there needs to be 2 decimal place values in our answer. And then we would write our decimal there. So our answer is 850. Okay, that's our answer. So let's go a little bit faster for the second example. So we're going to do 0.43 times, and then we do 10 times 10 is 100. Okay, so 0.43 times 100. 1 times 3 is 3. 1 times 4 is 4. We have the 2 zeros, right? Now we look. How many decimal place values do we have in our factors? Well, there's 2 for the 0.43. There's none in the 100, so we just have 2. That means our answer also has to have 2. So our decimal point goes after 2 decimal place values. So our answer is 43, okay? Now let's look at adding and subtracting. If we had something like $10 minus $1.25. I feel like this would kind of throw you off. We have to remember with whole numbers like 10, there are no cents. So we have to put a decimal and put zeros as kind of like placeholders, okay? And when we do our subtraction, now this is where you know what to do. You borrow across, right? This becomes a 9, a 10, a 9, a 10, right? You do your basic subtraction and we get our answer. But remember, when you have a whole number like 10, don't let that throw you off. You can rewrite it as 10 with 2 zeros after a decimal because we have no change in this case. Let's look at this other example. If I'm adding 1.7 plus 3.62. And again, I want to bring this up. When we're adding and we're subtracting, we need to make sure our decimals are lined up, right? So in this case, our 1.7, we have the 7 in the tenths place, but we have nothing in the hundredths place, right? So we can add a 0. We can add a 0 there. And that way now we can just add up. 0 plus 2 is 2. 7 plus 6 is 13. Now we have 5 over here. And where do we put our decimal? Well, again, we lined everything up, so we just draw the decimal right under everything else, right? And that's how we do it in this case. So for multiplication, we need to count the amount of decimal place values there are in the factors that we're multiplying, and that will be how many there are in the product. And when we add and subtract, just make sure that you line up the decimal when you do so. And you can add in zeros, right, as placeholders wherever you're like missing a number, okay? All right, so now I want us to look at this word problem. And this was one, I kind of rewrote it, that you struggled with a little bit. And we were talking about figuring out the cost of flowers. And in this case, I said we're going to do the cost of paintbrushes, okay? And so we have two different prices. We have the prices of one brush, okay? And then we have the prices of one box. But in each box, there are 40 brushes. So this says Miss Adams needs to buy 220 paintbrushes for her art class. At the prices shown, how much would she save if she bought them by the box instead of separately? And so I like what you thought. We're going to do multiplication, right? That's what we've been doing. We're going to take the number of paintbrushes she needs, the 220, and we're going to multiply it by the cost, right? We're going to multiply 220 by 1.56. And again, in this case, I would let the 0 dangle off, and we'll add that later on. And then I would do our multiplication, okay? And you know how to do that, so I'm not going to work through it all. And that would be, so this multiplication I have set up right here is 220, the amount of paintbrushes she needs, multiplied by $1.56. So this would be to find the amount it costs per paintbrush by buying them separately, okay? Separately. But now we want to figure out how much it would cost per paintbrush if she bought them in boxes, right? So in this case, we have to think about kind of like the units. Like, what are we really doing? So if we do 220 times the cost, which would be, let's say, times 30, right? That gives us the amount of boxes, but we need to realize there's 40 brushes per box. So we're going to have to divide that answer by 40, because what we're really doing is 220 times $30 per 40 brushes, right? So we can multiply 220 by 30, but eventually we need to divide by the 40 brushes to figure out the cost per brush, because that's what we're trying to figure out, is per one brush, okay? So I hope that makes sense. So if you come across that on the test where you see something like this, amount per one box, make sure you divide at the end the amount of items there are in the box or in the flat, whatever it's called. And then we do our subtraction, right? So we subtract the cost that we got from the separate, and we subtract the box that we got, the value. And that way you find the difference, okay? The last thing I want to talk about is with change. This is something that I also saw you struggled with, is when it says how much change does she receive back, okay? So change means we're going to subtract eventually these values, okay? So it says Molly spends $5.26 on candy, $8.19 on cookies, and $12.69, okay? So you're going to add all of these values together. And whatever value you get, you're going to subtract that from the $1.40, okay? So yeah, maybe we can do this really quick. 18 plus 6, we're going to have 24. 4, 11. 8 plus 1 is 9. 11, 16. Okay, so we have $26.14 is how much she spent. And they want to know how much change she will get back if she gave them $40. So whatever value we start with is the 40. That's going to be on top. And we're going to subtract the amount that she spent from the 40 to figure out our change. And again, when we add or subtract decimals, okay, we have to make sure the decimals are lined up. And in our word problem, they just said $1.40, right? They didn't have a decimal with 2 zeros after it. So we just have to remember, if we have a whole number, if we only have dollars, right, we can also put zeros as placeholders where there's no change in order for us to borrow, okay? So now we do our basic subtraction. We borrow across, okay? 10 minus 4 is 6. 9 minus 1 is 8. We have 3, okay? So there we go. So we get $13.86 back. So I hope this is helpful. Message me if you have any questions, and good luck on your test.